In this presentation, we're going to look at working with truth tables for logic. So here's some truth tables right now. We have 0 and 1, combinations of 0 and 1 for P and Q. 0 represents false, 1 represents true, and we have 4 combinations of 0 and 1, true and false for P and Q. The first column we're going to look at is not P. So essentially, it's the negation of P, it's the opposite of P, so to speak. So if we get 0 here, that means we'll have 1 here. We have 0 here again, we'll have 1 here. We have 1 here, and the opposite of that is 0, and again 0. Not Q, well, we're just going to do the same thing with the second column. 0 is, or we have 1 here, we have 0 here, we have 1 here, and we have 0 here. The next column we're going to work at is P and Q. So if P is 1 and Q is 1, we would get a 1. They're both true. So in this case, the only place we're going to get 1, a true, is down here where they're both 1. P and Q are both 1 individually. All of the other rows, all of the other entries for this column are 0. The last case we have P or Q. And in this case, either P has to be true on its own, or Q has to be true on its own, or both are true. So there's only one case where we get a 0, where they're both false, 0, 0. And for the rest of the cases, we'll get all 1s. So that's the truth tables for the most commonly used operations. We're going to continue now with something a bit more complex. So we're going to use truth tables to prove this identity here. So we have this term over here. It's a biconditional. I'm not going to introduce it, but I will sort of put down the appropriate truth table column for that. We have the logical OR and logical AND symbols and the negation symbol there as well. So we have pretty much met all of these symbols before in the previous slide. So there's very little new there. This symbol here means equivalence, and it means that this set of terms over here is equivalent to this. So okay, we'll move on. So I've filled in some of this already, for particularly the the negations and so on. Also, I've put in the truth table column for the biconditional. We're not going to look at what this is in this particular presentation, but it is something worth looking at in a separate presentation. So I'm going to start over here on the side. I have P and Q, and the first term we have to deal with is P and Q. So what I'm going to do there is do the same operation I've done previously. I'm just going to go through quickly because we've seen it before. 0, 0, 0, and 1. Where is P and Q the same value? Or where are they both 1, actually, I should say. So just that's the only one particular instance down there. We have one right down at the bottom. So we have the negations now here. So the negation of P and the negation of Q. And what we're going to do is perform the logical AND operation again. And in this case, we're going to go and see where we both have a pair of 2 1s in the respective columns. And in this case, we have 1 and 1 up at the top row. 1 and 0, so we get a 0 here. 0 and 1, we get a 0 here as well, and 0 and 0, we get a 0 here as well. Now, the next step is this union, or OR. Okay, so it's where, and we're going to be looking at this row, and this column, that column there, and this column here. And what we're going to do is decide if we have a 1 and at least one of the respective columns. So what we're going to do is look at the first row here. We have a 0 here and we have a 1 here. So we have a 1, we have 2 zeros, a 0 here and a 0 here, 0, 0 here and a 0 here, 0, and a 1 here and a 0 here. So we have 1. So this is our resultant truth table column. Now, lastly, it's important to state that we have derived this column here and we expect it to be the equivalent to this column here. So it's an important to actually state that these two columns are equivalent to each other. They have the same values. And that